next to it, and this has the information on the circles unit. In this picture here, we can see that the diameter is any point from the inside of the circle to another side of the circle, with this middle point in between. It could be from here to here, there, really anywhere, as long as it has this point in the middle of it. A secant is any point doesn't have the center in it, and it crosses it out, but the line keeps going, which is unlike a chord, which stops from one end to another. And this is a tangent here, and what makes it a tangent is because it touches the outside of the circle, and it's in a straight line. It doesn't go through this point, and it's not in the inside of the circle. It's on the outside, and it keeps going straight. The point of tangency is the exact point to where it touches the circumference of the circle, and the circumference of the circle is when it goes all the way around the circle here. So these notes here explain that this portion right here is called an arc. For example, when you have like a pizza, it would be the crust. So if you had a slice of pizza, the arc would be the amount of crust you had right there in that sliced out portion. And the circumferences again would be the crust all around the pizza. They can be measured in degrees or another unit of measurement called radians. And this is the degree of the arc is equal to the measure of the central angle. So if this was 120 degrees, this would be 120 degrees also. Because this is the central angle, angle ACB would be equal to the angle of AB. And this says that this is a fraction of the circumference. So in total, this would be 4 over 3 pi units from A to B, then what it would be of the whole entire circle. And what this says is that if the radius is 2 units, the circumference would be 4 pi. So this would be the radius right there or here. And the given information is that it equals 2 units. So we know from that the circumference is 4 pi. And the central angle is 120, and we can use that information, and we can tell that it takes up 1/3 of this entire circle. So the length is 1/3 times 4 pi, which equals 4 over 3 pi units. And a sector. So in a pie or pizza, it doesn't really matter whichever one floats your boat. It would be a piece of that circle that would be cut out, and it would be like the shaded region here. So it's between this radius, and then this portion on the outside of the circle right there. So this says basically down here in the green that the sector area is equal to the diameter, which is from here to there, over 360 degrees, and we get that from what would be all around in the circle, times pi radius squared. And not D does not equal diameter, D equals the measure of CAB, which is this angle right in A right there. So from there to there in the shaded region, that would be the central angle. And this says to find the arc length, you use your central angle here, which would be CAB, which equals 120, so we can use that over 360 times 2 pi r to find this length around the circle in the shaded region. So that would be the crust of the slice of pie or pizza that you just got. And in this example, if the radius equals 10 and the angle measures 120, then you can use the formula, plugging in the 120 there and the information, and you can find your sector area and arc length using that. Now, you can use degrees for angle measurements, but you can also use another unit of measurement called radians. So, it's a unit of how many of the radius can go around the portion of the circle. So if they said a radius of 2, then you would try to figure out how many of these radiuses could go into this portion of the circle there. 1 radian has the arc length of 1 radius, so it's all the same. All arcs in the same sector have the same degree measure. And this picture here just shows how the different circles and how they would vary from a smaller circle to a bigger circle. And from the notes from the Khan Academy that I watched, some basic ones would be 2 pi radians equal 360 degrees, and this would be used when you're trying to convert degrees to radians or vice versa. And 180 degrees would be pi radians. And to get 1 radian, you would just divide both sides by pi, and that's why we get this here. And so 1 radian would be equal to 180 over pi degrees. And you can see that, that's how we got that over here. And in radians, it is the arc that subtends the angle. So over here, this is called theta, and that is the central angle, is what they're calling it in the video. And it's equal to the length r, the radians. Radius is. So if we know that instead of degrees, that we know that this central angle, or theta, is equal to 1 radian, then we can figure out the arc length there based on that information. And over here was an example problem that they had. So a circle, you have the radius right there from the central point to the edge of the circle. And going all the way around 360 degrees, that would be equal to the central angle, or theta, would be equal to 2 pi radians based on what we know about the conversions. And to figure that out, there's an equation that you can use to define the angle in radius. You would use pi divided by 180 times your angle in degrees when it's given. And to find the angle in degrees when given the radians, you would use 180 degrees over pi times angle in radians, which is what it explains in this slide over here too. This is just another way to write the same problem. So to find this, d equals your central angle, your angle measure in degrees, and r would be your radians. So when given degrees, you would need to know the radians they give you times 180 over pi. And to find the radians, you use degrees times pi over 180. And you can also use it, set up a proportion, and do it the same way by multiplication, division, solving for unknown variable. These two circles here represent a conversion chart. So over here you can use the most common degree angles and convert it to radians very easily. So if you know that 0 degrees is right here, and then you go to 90. So you have 90 degrees from here to here. Then that would be 2 pi over 2 radians. Right there. And then over here we have the same thing that we know of. Degrees, radians, simple ones that are bigger amounts of so we can convert the two. We know that this is an inscribed angle, so we use the central angle C over here, and so whatever this angle is here, this is going to be twice as big. AB is going to be twice as big as this amount over here. So if we know that this is equal to 40, angle C, then AB is going to be 80, as an example. And then we can also, it's a right angle triangle over here, and we know in right angle triangles that this would be equal to 90 degrees. And when this inscribed angle intercepts the circle at the diameter, the measure of the angle is 90 degrees, because you can use this line right here and chop it right down the middle, or this way. And when these 2 points meet together in the center, from A and C, they meet over here at B, then that equals 90 degrees, because that's a perfect intersection. And with inscribed angles, they always have the vertex on the circle, on the outside, the circumference of like the crust. So over here at C, and in this picture, the vertex would be B. And this is where more lines come in at different points, is because a line that passes through one point on the circle is called the tangent line, as we talked about earlier. So from A to this arrow over here, that's the tangent, and this D would be the tangent point on this circle. And it forms when a radius measures 90 degrees. So you have this angle here, and then the tangent is always a straight line on the outside of the circle, and it's always going to form a 90-degree angle. So we can use this information to determine the angle BAD, which is this angle right over here, plus BCD right here. So we have x plus 180 minus x equals 180 degrees. So this angle plus this angle will equal half of a circle. And we know that ABCD is a quadrilateral because of the 4 sides there with the 2 radiuses, and then on the outside with the 2 tangent lines. And where these 2 angles meet measure 90 degrees, but due to it being a tangent right there at angle D and at angle B on both sides. And over here it just describes that this angle was created because of the tangent lines. That's what makes it happen. Secant lines intersect the circle at 2 points.